Hi there. Well, we're going to be looking at 7.3, which is adding, subtracting, and finding the least common denominator. Probably maybe this section isn't bad because all the denominators are going to be the same. So if we look at this first one, A over B plus C over B, these are the same. So we have, as an example, we would have maybe 1/8 plus 3/8. Which gives us 4/8, okay? Which isn't too bad. And then of course we need to reduce. So 4 goes into 4 once, 4 goes into 8 twice. So when you have the same denominators, you just combine the numerators. Notice that I did not add the denominators together. So one mistake that I've seen before is to take the 8 plus the 8, and people want to put a 16 here. Now, if you're multiplying, you do multiply. But when you're adding, if you've got 1/8 plus 3/8, you end up with 4/8. So again, don't add those denominators. Just add the numerators together. In subtraction, the same idea. If you had, let's say, 5/8 subtract 3/8, common denominator, you end up with 2/8. Just subtracting the numerators. Now this has some issues when we deal with algebra, which we'll talk about. But then you reduce the 2 and the 8, and you come up with 1/4. So we are going to have to do some reducing at times, which goes back to section 7.1, where you have to factor in order to reduce. So let's go ahead and get started. And again, this section isn't really too bad because the denominators are the same. So looking at this one, add and subtract and simplify. Here, let's see if I can get that to focus maybe a little bit better. Let's see, one more. Let me see if I can get it there. Okay, looking at this A here, we have the same denominator, x's. So what we're going to do is we're going to add the numerators together, and our common denominator is an x. So again, I'm not multiplying those denominators together, I'm just carrying them over. So don't put 2x, you don't add them, you don't multiply them, it's just an x. And then we'll go ahead and we'll add the numerators together, 3 plus x plus 4. So we're adding those numerators, and then you simplify. So that gives us x plus 7 over x. Now, can this be reduced? Well, some people would want to reduce the x's and cancel the x's. Well, don't do that, because we stressed in that first section that x plus 7, it goes as a group or it doesn't go at all. So again, make sure you do not cancel those x's. They cannot be canceled. So the x plus 7 goes as a group, or they never go separate. They never go separate. So that is your answer, x plus 7 over x. So if the denominators are the same, you just add or subtract the numerators. It's that simple. Well, let's try another one. So this one right here, the denominators are the same. They're both 2x plus 1. So I will put that common denominator here, just like I did up above with the 8s. Then it just comes over to be an 8 here. So 2 plus 1 is your common denominator. So I'm going to add the numerators together. So that gives me 2x. I'm just going to go ahead and rewrite them. Plus 3x minus 7 plus x squared plus x minus 8. And I'm going to combine the like terms. So we end up with 3x squareds, adding the x squareds. Now let's see, our x's give us plus 4x. And minus 7 and a minus 8 give you a minus 15. Now, the key is can you reduce this? Would you be able to factor this out and come up with something that would cancel with this? And here in this case, we know it could never reduce because I have a 3x times an x gives me 3x squared. I automatically know I don't have that 2x in either spot. So this means you're done. It cannot be reduced. There's your answer, 3x squared plus 4x minus 15 over 2x plus 1. So there are times where you may need to factor this, but in this case, it can't be factored in order to cancel the 2x plus 1, because we know we're not going to end up with a 2x for this right here. Okay? All right, let's try another one. Again, this last one, this C, we have a common denominator of x squared minus 9. And so I'm going to go ahead and I'm going to add the numerators together. I have a plus sign here. So that gives me x minus 5 plus 2. Now, combining our like terms, we end up with x minus 3 over x squared minus 9. Well, the numerator cannot be canceled, but the numerator cannot be factored. But let's see if we can factor the denominator and cancel, if possible. X minus 3, and so you need to factor in order to reduce. Let's see, we're going to go ahead and factor this. X times x is x squared. It's a possibility because we have an x in both spots. Minus 3 and plus 3. I have a difference of 2 squared. And I have two groups that match. So these would cancel and form a 1. So your answer is a reduced form is 1 over x plus 3. So really in this section, this is going to be the harder part, is knowing when to factor and maybe when it is not going to do you any good to even try to factor because the groups have to match and there's no way you're going to get a 2x out of these two first terms. Okay, all right, let's see. Let's go ahead and try another one. This one's a little different. This one is the subtraction. You're going to have to be careful with subtraction, and I'll show you here in a minute. We've got x, our common denominator. Let me move this down a little bit. All right, we have x plus 2 as our common denominator. Now, when you subtract, you have to use parentheses here. All right, it's really important that you do that. So that subtraction symbol, this subtraction symbol, will change the sign on everything in the numerator. Okay, so that's just something to be aware of and to be careful of. 3x minus x plus 5. So the x becomes a minus and this subtraction becomes an addition. So whenever you have a subtraction, it will change the signs in the numerator every time. All over x plus 2. So that, just be aware of that as you're doing your homework. Watch for that. So here, we're going to end up with, I'm just going to do that over here so I don't run out of room. 3x minus x is 2x plus 5 in the numerator over x plus 2. And you ask yourself, can this be reduced? Well, you cannot factor anything in the numerator. You can't factor anything in the denominator. The groups don't match, so you're done. Because you can't factor either one of those, and they don't match, so you can't reduce. So that would be the reduced answer. So again, one more time. If you have a subtraction symbol, put it in parentheses here, and remember, or just when you rewrite it, it'll be a minus x plus 5. Change the signs in the numerator that follow that subtraction symbol. All right, let's try another one. You guys are doing great. Okay, here we have common denominator. So what we're going to do There's my x minus 4. Okay, when we look at the numerator, we keep the first one, x squared. Then we'll have a subtraction. This is a subtraction, but you need parentheses. And remember, here we have a common denominator here. That's x minus 4. That you will change the sign. So that'll become a subtract x. And that'll become a subtract 12. That's the hardest part in this adding and subtracting in this section, is remembering to change the sign in the numerator here. Change those signs there. So it's minus x minus 12. So then simplifying here, I guess we'll just move this over a bit. Let's see if we can factor this. Let's see. Look for the greatest common factor. There isn't anything. So we'll go x times x. It's a possibility, so I'm going to keep going because I have an x here. So it could match one of these. Let's see, we've got a minus 12. Well, that could be a minus 4 and a positive 3, or a minus 6 and a positive 2, using your guess and check, or a minus 12 and a positive 1. These multiplied together give you a negative 12. This added together gives you a negative 4, this first one. But we don't have a negative 4. So these two added together give you a negative 1. So we'll have a minus 4 and a plus 3, because we want that negative 1, and those give you the negative 1. Well, it just so happens that our groups match, so we cancel them, and your answer is x plus 3. So if the denominators are the same and you're subtracting, when you do combine the numerator, make sure that you change the sign on that second fraction, the numerator of that second fraction. And then once you've done that, you combine similar terms. And in this case, there weren't any similar terms to combine, but we were able to factor and simplify. So again, always check to see if you can factor and simplify. Okay. All right, that pretty much covers half of section 7.3. And that's the adding and subtracting with like denominators. What we're going to work on now is for information for 7.4, which is how do you find the least common denominator, so that you can change these so that you have a common denominator and you can add or subtract them. Now, when you're multiplying and dividing, that's what makes multiplying and dividing so much easier, is that you don't have to get a common denominator. You can just simplify, you reduce, multiply across, and you're done. So adding and subtracting fractions, you need a common denominator, the least common denominator preferably, so you don't have to reduce so much. And then you can add or subtract the numerators, and then reduce when you're done. So let's go through some strategies on how to find the least common denominator. So we've got 2 of these right here, and all they want is the least common denominator. How do we do this? How are some strategies here? Well, we've got 36. I'm just going to write them separate. 36x squared and 24x. I want something that they go into. It's not the greatest common factor like what we were doing in chapters 5 and 6. What would go into them, but what will they go into evenly? So what we need to do, would somebody please take care, is we're going to break these down. Now, some of you may be able to look at 36 and 24 and say, oh, they'll both go into this number. But let's say if you can't, what are some strategies to find that? Let's go ahead and we're going to break them down. And I'm just going to go ahead and break them down into primes, both of these beginning numbers. So this is a 3 squared times a 2 squared. And I still have the x squared. So what I've done is I have rewritten 36x squared into primes. Okay, so I started, you could have started with 9 and 4, it doesn't matter. And Then you break those down, and I've got 2 3s and 2 2s, and then you have the x squared. Let's do the same thing with the 24. 24, let's say 8 and 3. And 8 is 4 and 2. So you just break them down into primes. And the 4 goes down to 2 and 2. So I've taken care of those. And now rewrite these in with exponents. So this would be 2 to the third. I have 3 of those, times this 3 times the x. Okay. So I now have rewritten those in prime. So I've got this as the 36x squared and this as the 24x. So when you find the least common denominator, first off, we're going to start with, you pick any number like the 3. I've got a 3 squared here, and I have a 3 to the first here. You always choose the largest one, because I want these to go into here. I want these to be able to divide into here. So then we look at, that takes care of the 3s. Then we look at 2 squared and 2 cubed. Well, I use the largest one, 2 cubed. Okay. Then I've got an x squared and an x, and I use the x squared. Now everything that appears here has to be found here. So I have 3s, I've got the 2s and the x's. So there's your answer, except for we're going to multiply it out. They want you to multiply it out. So this right here is 9 times 8 times x squared, which is 72x squared. That is your least common denominator, 72x squared. So again, just kind of going through that, break them down into primes. Okay, use exponentials when you rewrite them. 3, I have 2 of them. I have 2 2s, and then I have the x squared. As far as 24 goes, I had 3 2s, a 3, and an x. Now, when you go to write your least common denominator, you look for the largest power of everything. The 3s, it was a 3 squared. The 2s, it was a 2 cubed. X's, it was an x squared. And then you just multiplied, and there's your least common denominator. All right, let's practice some more. See what we can do. All right. Now, sometimes you don't have to break them down into primes. You just know, you can just look at them and say, oh yeah, I know what that is. But let's go ahead. Here are my denominators. These are denominators, and I want the least common denominator. So, you know, once you've determined that, then you can rewrite the numerator, but we're just looking at least common denominator. In other words, this could be an example of maybe 1 over 15a we wanted to add, and maybe not 5, 6, 8 over 35b. Let's say I wanted to write those, I wanted to add those two fractions together. Well, I can't add them right now because the denominators are different. They need to be the same, they need to have the same size. So I'm going to have to find the least common denominator for these right here. And that's what they're asking. They're just not giving you the numerators, just the denominators. Let's do the same steps that we did in the last one. 35b. Okay. So here you can, you know, and you guys can always stop the video and try these on your own and see if you get the right answer. You know, that would be a good strategy in learning these, because you learn more by doing rather than watching. But let's go ahead and go through the same strategies of breaking it down using our tree diagrams. First off, let's look at 15. Well, 15 is 5 times 3. Okay. We're done with the primes. We've got 5 to the first, because we have one of them, 3 to the first, and then don't forget your variable a. There's our first one. And again, what we're trying to do is trying to find out what 15 and 35 both go into. And let's see, this one right here, let's break it down. 7 times 5. They're both primes. We're done. 7 to the first times 5 to the first times, don't forget your variable b. So now I have these two. I've rewritten 15a in primes, 35b in primes. So the least common denominator is, let's start with doesn't matter what number you start with, let's start with 5. Okay, I've got a 5 here. I also have a 5 here. The largest power is 5 to the first. So whenever you have it, you always look for the highest power of anything. So 5 to the first, and you can cross off your 5s, they've been taken care of. The next number, let's pick the 3. All right, I've got a 3 to the first. I don't have anything higher, so I'm going to use 3 to the first. So you break them into primes, and then you just take whatever you've got. Let's see, this next one, we've got a 7. And so let's see, we'll use 7 to the first. That's our highest power. So all the numbers have been taken care of. If I would have had a 2, I'd had to, in either one of them or both of them, you always just take the highest power. Now let's look at our variables. A to the first. There's no other A. That's the highest power, so we'll use it. B to the first. There's no other highest power, so we'll use B to the first. So there's our least common denominator, but we're going to go ahead and multiply them together. We'll take 35 or 15 times 7, which gives us 15 times 7 is 105. AB. A times B. Okay? All right. So are there any questions on that? So you just break them down into primes, and then you take every term here, every part here has to occur here, and you always just take the highest power. If it's in common, you always take the highest power. And there's your least common denominator. So 15 goes into 105, and 35 goes into 105. And then you can rewrite your fractions, which we'll do in 7-4. All right, let's try another one. So this is all we're going to be doing for the rest of this section here. Now, some of you can look at 21 and 7 and say, wow, I know what 21 and 7 go into evenly. They both go into 21. But let's say you didn't recognize the fact that 21 goes into 21 and 7 goes into 21. Let's go ahead and practice our primes, breaking it into primes just to make sure. Here, maybe I'll go ahead and rewrite it. Those are kind of small. Well, I think we can do it. So 21 is 7 times 3. That's it. They're already primed. So let's rewrite this one. 7 times 3 times x cubed times y to the 6th. Okay, it's all primes, that first one. Let's go to the next one, 7. Well, 7 can't be broken down. It's just 7 times 1. So we have 7 x to the 5th, y to the 2nd. That one could not be broken down like the 21. So when you look at these, well, let's see, I've got a 7. This one has a 7 and this one. And you take the highest power of the two. The highest power is 7 to the 1st. That takes care of the 7. I have a 3 here. I don't have a 3 over here, so I'll just use 3 to the 1st. That would be the highest power for 3s. I've got, there's our numbers. We're done with the numbers here. And of course, we got the 21, which we knew. I have an x cubed, and I have an x to the 5th. I use the highest power on these, which is x to the 5th. You use the highest power for that base. Y's, I use the highest power. You use the highest power on the number base and also on the variable base. which is y to the 6th. So my answer is 7 times 3, x to the 5th, y to the 6th. There is the greatest common factor. Okay. Now, C and D are a little bit different. We have to factor in order to find the least common denominator. So I need to factor. So just like I factored the 21, in other words, I broke the 21 in what times what gives me 21, or in the previous problem, I factored 5 times 3 gives you 15. I'm factoring these, I'm breaking them apart. What times what gives you this? So then I could look for the highest power. Well, we're going to do the same thing here. We're going to factor these. What times what gives you this number? And then what times what gives you this? And to do that, we factor it. Look for the greatest common factor. Nothing. So we're going to factor this just like we did the 15 and the 35 above, or the 7 and the 3 with the 21. So we're going to break it into multiplication. So we're doing this one here. X times x gives you x squared. We want a minus 6, but when we add them, we want a positive 5. Well, that's going to be a positive 6 and a minus 1. Multiplied, you get a minus 6. Added, you get a positive 5. Neither one of these can be broken down. So we're done factoring this one. We would say they're prime, like up above, like the 7 and 3 could not be broken down any further with the 21. Okay, the 7 and the 3 were done. We're done with these. So let's go over. I'm just going to move the x squared minus 2 over here, or x squared minus 1 over here. We're going to factor it. We have x minus 1, x plus 1. So we have a difference of 2 squares. Okay, we're done factoring. So we're going to take each group and we're going to look for the highest power on each of these groups. Okay, let's see. We've got an x plus 6, and I don't have a higher power anywhere. So x plus 6 is part of the least common denominator. That'll take care of this one. I have an x minus 1, and to the first power. I have an x minus 1 to the first power. So I will take x minus 1 to the first power, and that'll take care of both of those. The only thing left is the x plus 1. And to the first power. That's the highest power on the x plus 1. So each of these is taken care of down here in this. Each of these is found down here. And again, the only one that was the same was the x minus 1 and just to the first power. You're done. I would not multiply that together. I would just call that your least common denominator. So you're factoring and looking for the highest power on every group once it's factored. Let's try another one. I want the least common denominator if these are my denominators. So we're going to factor them just like we did the 21, the 35, the 15. We're going to break it into parts. So here, let's go ahead. Let's break this one down right here. Again, look for the greatest common factor, which would be t. That leaves you with t squared plus 4t plus 4. Okay. Now, this can be factored. So we're not done. This can be broken apart. Just like we had that 8 on the previous page. You know, we broke the 8 down into 4 and 2 and 2 and 2. You have to keep breaking it down until you can't any longer. Okay, so breaking this down, we've got t times t gives you t squared. 2 times 2 gives you 4, and added together gives you a positive 4t. And don't forget to bring down that 1t that we took out. So you can't forget it, it goes down here. I'm going to rewrite this because notice that I'm going to go ahead and go to the page that we did previously. Let's see. Okay. Looking at this one, notice that I had 2 3s and I wrote it as a squared. And I had the 2 2s, so I put that. Or even with like I had 1, 2, 3, I had 3 2s. Okay, we're going to do the same thing with this one. I'm going to write exponents if I have the same thing, because I had 3 of them. So here I have 2 of these. So it's important that you write it like that. Okay, for your least common denominator, I have 2 of them. So now let's go ahead. So this is the least common denominator for our first fraction. Let's go, or for our first denominator, let's go to the next one. And I'm going to rewrite it. And let's go ahead and we need to break it down. We need to factor it. So we're going to take t, greatest common factor of t. That leaves you with t minus 4. And again, if you multiplied it, you'd go back to the original. And it looks like it's done. We don't have to factor, we can't factor the t minus 4. It can't be broken down any further, and we can't, the t is the t. So we have, I'm just going to write it down here closer to our other one. So those are the denominators, and these denominators have been broken down. So now we look for the highest power of everything. And that's why it was so important that when you have 2 of something or 3 of something, you write it as an exponent at this point. So when you factor it, write it as an exponent. Let's start with the t. I have t to the first. I have a t to the first. So our highest power on just this t here is t to the first. Then that'll take care of these t's right there. Just cross them off, I guess. You don't have to, but I will. We have t plus 2 squared. That means I have 2 of them. There aren't any over here, which means that's the highest power. T plus 2 squared. That'll take care of that one. And then over here, I have to, everything has to be crossed off. So I have a t minus 4. The highest power is t minus 4 to the first. And you're done. So there is your least common denominator. So again, you're factoring, and if you do end up with 2 of something or 3 of something, make sure you write it as an exponent. If we would have had another t plus 2, I would have had it cubed here. But that wouldn't have been fun factoring, so let's not do that. Okay, now what happens if we have 3 fractions that we're going to add together, which we will tomorrow, or not tomorrow, but in our next section. Let's look here. I have, this is a denominator, this is a denominator, and this last one. Well, this first one cannot be factored. Let's just write that as, we'll leave that as x minus 3. This one can be just written as x plus 3. It cannot be broken down. Neither one of those can be broken down. But the other one can. Our last one can be factored. This is x times x, minus 3 and plus 3. There. Okay, so now we have our broken down fractions here. We broke them down. We factored them if we can. Now let's look for the highest power on each of these groups. Let's start with the x minus 3 since it's first here. We have an x minus 3 to the first, and it looks like there's another x minus 3, but it's also to the first. So we're just going to use it to the first, our first power. So that gives us x minus 3 to the first. That'll take care of both of those. We take the highest power once they're broken down. Then we have an x plus 3 in our next one. And the highest power of any x plus 3 is an x plus 3 to the first. Because that's to the first, and that's to the first. So we'll use it to the first. And there is your least common denominator, and don't multiply them. MyMathLab should accept those. Well, that's it. So all you need to do for this section 7.3 is you need to make sure that you know how to add. Make sure that when you're adding that if it has a common denominator, which in this section it will, you just add the numerators, and sometimes you may have to simplify. You may have to do some factoring and simplifying, but again, it's just adding the numerators. And then if you look at the subtraction, subtraction can sometimes give you fits. But if you do have this subtraction here, make sure that you change the sign on everything in that numerator that follows. Minus x plus 5. So if you make a mistake, sometimes that's a pretty common one to do, is to forget to change the sign in the numerator following the subtraction. And then looking for the greatest common factor, or excuse me, the least common denominator here, you factor them, you break them into parts, and then write them with exponents once you've done that. And you take the highest power of everything in both groups. So like in this one, we had a 3 squared was the highest power, 2 cubed was the highest power, and an x squared was the highest power. Now, when you're doing these, go ahead and multiply them together and get the 72. But after you get the highest power, like on this one right here, this D, don't multiply them. Don't multiply them together. Just leave it. It'll be a lot easier to find the numerators. Okay, that's it for 7.3. And if you have any questions at all, please contact me, and I have the document camera. We can go through some more samples. But I need to hear from you if you have questions, so that way I can help you out. All right. Well, thank you, and I'll open up this assignment. And just let me know again if you have questions.